Okay, this is going to be part 2 of the Honors Unit 2 test review, and we're going to do the portion that says wavelength, frequency, and energy. Up on the top, you're going to see just your formulas, and then I also have the constants written out, and I defined what the variables are. So that's there. Use that to as a reference for the rest of the problems. Okay, so the first problem says a certain blue light has a wavelength. I'm just going to box that because it's a given, of 4.56 times 10 to the negative 7 meters. Part A says, what is the frequency? So I'm looking for frequency. So then we're going to look up to our problems and figure out which ones we should use. Okay, I don't see anything about energy, so I don't think it's going to be that one. So I'm going to use this formula right here. C equals lambda V. The lambda is the wavelength, and we are looking for V. We are looking for frequency. So I'm just going to write that out. C is equal to lambda times V. We know C. You know C because it's a constant. Here is our C. It's the speed of light. 3.08 times 10 to the 8th. This should be to the 8th power. 10 to the 8th. Okay, so we know that 3.0 times 10 to the 8th meters per second is equal to lambda, which we have. That's the wavelength. 4.56 times 10 to the negative 7 meters. And what we are looking for is frequency. We do not have the V. We want to get V alone, so because these are multiplied, if I divide on both sides, so divide by itself to cancel it out on this side, and divide on this side. So I'm going to divide 3.0 times 10 to the 8th divided by 4.56 times 10 to the negative 7, and that will get me V. So I'm going to put that in my calculator. Okay, so let's see, so I can see my numbers at the same time. 3.0. Okay, remember we use our, if your calculator will probably have either a second EE or just an EE key. If you have that, it will save you from having to do times 10 with a caret. So if I just push this EE, I don't have to use times 10 or a caret. That replaces all that. So I only have to put in the exponent 8 divided by 4.56. Again, that EE is a negative 7. And then I hit enter, and there's my answer. Alright, so as far as thinking about sig figs, if I was going to use those, I'd be looking for 3 because of that 4.56. So that is going to be, the 7 is going to round up, so it would be 6.58 because that's going to round up times 10 to the 14th power. So V is equal to 6.58 times 10 to the 14th, and don't forget to include your unit. So my unit for V is seconds to the minus 1, and that is my answer. So the next question says, what is the energy of this light? Now for that, I'm going to use a different equation. Let's see if I can switch pens. Well, I'll use the same one. So I'm going to say E is equal to HV H times V. We just solved for V, so V is right here, and H is a constant. There's H. It's Planck's constant. Once again, this should be a superscript, so that should be times 10 to the negative 34 power. So I'm just going to plug that in. I'm going to say 6.58 times 10 to the 14th multiplied by our Planck's constant, which is 6.626 times 10 to the negative 34. And I'm just going to plug that in, and that will give me E. So 6.58 to the 14th power times 6.626 E to the negative 34. And there's my answer. So I'm going to say 4.36 times 10 to the negative 19th power. And that is my E. There we go. Alright. For the next problem, it says, what is the energy? So E, I'm solving for E. This is my unknown. Of a light with a wavelength. So we have wavelengths. This is my known. So we have the lambda value, right? We have this right here, but we don't have enough information to get straight to energy, this one. So what we have to do is first solve for frequency by using this equation, then we are going to be able to find energy. The first thing I'm going to do is solve for V, right? So I'm going to solve for V before I do anything else. So I'm going to say, I got to do this one. C is equal to lambda V. C is a constant, once again. It is the speed of light, so I'm going to say 3.0 times 10 to the 8th. Okay? And just like before, I'm going to end up dividing this, just like in the previous problem. I'm just not going to write the whole thing out, but I'm going to end up dividing that in order to solve for V. Because remember, in order to solve for this unknown, we need to take the C and divide it by the lambda in order to get V. So I'm just going to do that directly. Okay, so I'm going to say 3.0 times 10 to the 8th power divided by 5.84 times 10 to the negative 8 is equal to. That's what V is equal to. So 3 to the 8th divided by 5.84 to the negative 8, and that gives me, and I'm going to go with, again, 3 sig figs, 5.14 times 10 to the 15th power. So V equals 5.14 times 10 to the 15th power. Oh, you know what? I just realized I need to put in units. So my units, again, is that seconds. And I didn't put my unit up here, so I'm going to make sure I go back and do that. So my unit for energy is going to be in joules. So I'm going to add that J up there. Don't forget your units. You don't want to lose points for that. Okay, so now I have my V, which means I can go back to my original question, which is energy. Because energy equals H times V. So we just solved for V. So I'm going to use my Planck's constant again, my H, which is up here. So I'm going to say E is equal to 6.626 times 10 to the negative 34 times my V, which is 5.14 times 10 to the 15th. And that will give you my energy. So I'm going to get that in there. On mine, I just did answer times. since I already had it, it's still saved. So this is just my V, so now I'll put in that E. 6.626 EE key, -34, and I'm going to hit enter. There it is. It is with 3 sig figs. I'm going to say it is 3.40 times 10 to the -18. So 3.40 times 10 to the -18. And again, don't forget your units. My units for energy is joules. I'm going to box my answer. Alright. Next one is asking what is the energy. So again, an E problem. What is the energy of a photon microwave radiation with a frequency, here's my given, of 7.21 times 10 to the 11th hertz. So this one's set up a little bit differently because we actually can use this directly since we already have our frequency. Okay, so my frequency, so it's E is equal to H times V. So E is equal to our Planck's constant, which is that 6.626 times 10 to the -34 multiplied by the frequency, 7.21 times 10 to the 11th. So I didn't have to do a lot of extra steps in this one. I'm just going to put it in my calculator. E -34, okay, times 7.21, use your EE key, and enter. There it is. 4.77 repeating, or not all the way repeating, so 4.77, which is going to round up to be with our sig figs. Let's see. We're going to use 3 sig figs since we're going to look at this to give our sig figs. So that would be 4.78 times 10 to the -22. And again, our unit is going to be joules. J. Okay, what is the wavelength of this radiation? So, what is the wavelength? Okay, we're going to use our frequency up here, and then we're going to use this equation, this right there, to give us the wavelength, the lambda. So right now we are going to be looking for that lambda value because we have the speed of light, we have the frequency. Okay, so students are always ask me, how do I know what to use? And I say you have to read the questions and kind of apply them critically. Anything where energy is involved, you know you're going to be using this equation. Okay, if the wavelength is involved, you know you're going to need to use this equation. Frequency could be in either, so those aren't good ones to use. So I'm going to say C is equal to lambda V. C is the speed of light, so I'm just going to start filling in my variables. Remember, we're solving here for, the lambda. We're solving for the lambda. We have the frequency. Okay, so C is the speed of light. That is 3.0 times 10 to the 8th. And that is equal to lambda, which is what we're solving for, times the frequency, which is this number. That's 7.21 times 10 to the 11th power. And again, to get this by itself, we just need to divide it on both sides. So that cancels out over here. So if I divide these, that's going to give me my lambda value. So I'm going to plug that in. Okay, and it's small, but that's okay. Sometimes I think it's helpful to put it into scientific notation, right? So to do that, we're just going to drop it so there's only one digit in front. We're going to say 1, 2, 3, 4 times, and it's a negative number, so it's going to be 4.16. If I'm doing my sig figs, we're working off of 3 sig figs. Right, so 4.16 times 10 to the negative 4, because if I move it into scientific notation. So this one is equal to 4.16 times 10 to the negative 4. And of course we want to include our units. Our units here for wavelength are meters. So that's up there. Meters. Okay, last problem. Okay, here is our given, the frequency, 4.51. So remember, this is lambda. That's lambda. And now we're going to be, or I'm sorry, that's V, not lambda, because we're solving for lambda over here. This is our frequency, which is V. Okay, this is V. Frequency. We're solving for wavelength in this first problem, so again, C is equal to lambda V. So really, if we rearrange this algebraically, we're looking for C divided by V equals lambda equals wavelength. So let's write out our variables. So we're going to say C is the speed of light, 3.0 times 10 to the 8th, divided by our frequency, 4.51 times 10 to the 14th power, and that will equal our frequency. So okay. Once again, we are going to need to get this into scientific notation because we want, well, it just makes it easier to read in my opinion. So I'm going to move this 1, 2, 3, 4, 5, 6, 7 times to give me 6.65 times 10 to the negative 7. There we go. Oh, I have forgotten something very important, which is my unit. Don't forget your units. Okay, so for wavelength, our unit is meters. Last question. What is the energy? What is the energy? So for that one, we know we have to use this equation up here. So we have H and we have V, so it's just simply solving it up. So E is equal to H times V. So E is going to be equal to our Planck's constant multiplied by my frequency. Okay, there we go. I'm going to plug that in my calculator. Alright, here is what I got. It is 2.988, so if I'm doing sig figs, I am working off of this. So it would be 2.99 times 10 to the negative 19th power. Two 0.99 times 10 to the negative 19th power, and my unit is joules. Okay. All right. And that is it. So, if you have any other questions, please feel free to ask.